Okay, hello guys. Happy Thursday. Right. Uh, Welcome back from your holiday. All right. So, how was your holiday? This is our lesson for September week 2. Okay. So, if you still remember where we left off, we stopped around here. Which is the energy one. Oops, sorry. Forgot to erase this. Okay, real quick. Let me erase this for a while. So we stopped around 7.1. Okay, sorry, I just ate, so I'm a bit stuffy here. Okay, so holiday was boring. Okay. I mean, a boring holiday is a good holiday lah. That means you slept well. Okay, because I slept through my holiday. Didn't even go anywhere. Anyway, so we finished this, right? We finished what is work, energy, and power. Which was like what, 2 weeks ago. So we did learn that what is work, when you move something, so that's work. You need energy to do work. So energy and work, kerja and tenaga, they are the same thing. All right, and of course, what is power? Power is when your energy or work is divided by time. How fast can you do a work? So that's your power. So if you still remember, we have done all this, all the very easy exercise. So let's look at the types of energy today. Okay, today will be a very simple lesson. Also it will be a boring lesson lah. Guys, I know this chapter is very boring. All right, you just have to tahan for this week and tahan for next week. So when we go to chapter 8, right, that's when things get interesting, because chapter 8, if I'm not mistaken, we will learn about nuclear. That chapter is very, very interesting. Okay, because I have a video to show you. So meanwhile, you have to make do with this chapter lah. All right, it's boring. I know, because it really is. So anyway, we have talked about energy last week. Okay, the previous lesson. So today let's talk about 3 types of energy. Okay, today we are going to learn about 3 types of energy and how do you calculate them. This part will be out in your physics next time. That means if you go to Form 4 and you choose science stream and you go for physics, you will see the same thing. Right? So you will be learning this next year as well. So what are we going to learn? We are going to learn about potential energy and kinetic energy. Okay, I'm a bit stuffy, sorry. I just ate my dinner. So potential energy and kinetic energy. So what are they? In BM we call it tenaga keupayaan and tenaga kinetic. Right. So what is potential energy? What is keupayaan? So I think you learned this in primary school, right? So what is potential? When I say that you have a lot of potential, okay, let's say lah, I say, oh, this kid has a lot of potential. Potential means you can do things, all right? You have the ability to do certain thing, okay? So when I say that you have a lot of potential in sports, so that means you could go far, you could achieve something, all right? So potential energy is the energy stored inside you. You're storing an energy. When you release it out, you can use it to do work. So that's the meaning of potential energy. That it is a stored energy. Okay, tenaga yang disimpan. You keep it in a body or whatever. So this is your potential energy, and kinetic energy is the moving energy lah. When your car is moving, you have kinetic energy. Anything that is moving have kinetic energy. All right, and of course, our potential energy has 2 types. You have gravitational potential energy and elastic potential energy. So this thing, we call it tenaga. Let me write short form lah. Tenaga keupayaan gravity. All right, so guys, for simplicity's sake, for me not tying up my tongue, okay, because I don't want to keep saying gravitational potential energy, gravitational potential energy, gravitational. Okay, so I'm just gonna call it GPE or TKG in that sense. All right, GPE or TKG. And TKG is BM lah, tenaga keupayaan gravity. So what is this? Why energy? Why potential energy got two types leh? Because you have energy, you have potential energy stored in different places. If you store your potential energy in height, in ketinggian, that is your GPE. Okay, that is your GPE. If you store your PE, your potential energy, in spring, in rubber band, that is EPE, elastic potential energy. Okay, we shall go into that later. So this is your GPE when you store your energy in your height. All right. So you might say, sir, height can store energy on man. Okay, put it this way. Let's say this is a building, right? Let's say this is a building. Let's say this is 18 stories. Okay, 18 floors high. For you to climb the stairs, okay, let's say you say, you know what, screw this, I'm not going to take the lift. Only pussies take lift. I'm going to walk the stairs up. Right, good for you. So if you walk the stairs all the way up, okay, you should have like very swollen legs already, okay, very swole legs. But okay, I digress. So when you walk up there, okay, when you walk up there, what energy are you using? You're using chemical energy, right? Because 18 stories, 18 flights of stairs ain't no easy shit, man. You go and climb and see. Also, 18 flights of stairs, you'll be burning some energy. So let's just say you burn 200 calories. Okay, here I am talking about calories again, talking about losing weight again. All right, let's say you climb stairs to lose weight. Let's just say you burn away 200 calories. All right, so 200 calories, this is your chemical energy, tenaga kimia. As you walk up there, as you reach the top, the 200 energy is no more. You burn it already, right? You burn it away. But does it mean it disappeared? Does it mean it disappeared? Did you just destroy the energy? Like I said last 2 weeks, okay, like I said 2 weeks ago, energy cannot be created. Okay, energy cannot be created and energy cannot be destroyed. Energy cannot be destroyed. So you cannot destroy this 200 away. It has to go somewhere. So where is it? After you walk up all the way, you should have 200 calories worth of GPE. All right, so you did not just destroy this 200, you are just converting it from chemical to gravitational potential. From chemical energy to GPE. You are just converting energy. As I said, you cannot destroy energy. You can only you can only convert energy. So in this case, you convert this thing. You manage to convert this thing from chemical to, GPE. And let's say you decide to jump down. Let's say lah, okay? I mean, don't do this lah, guys. Anything can be solved, all right? So don't kill yourself. All right, anyway, so when you jump down, right, you should get 200 calories of KE, kinetic energy. Because as you move down, you become faster, right? You are getting kinetic energy. You are converting that 200 of GPE into KE, right? So again, I prove my point. I can only convert energy. I don't just lose it. I don't just destroy it. And the moment you hit the ground, okay, the moment you hit the ground, you should hear a loud bang, like bang. Because, I mean, if you jump down from a building, takkan the thing when it reaches the ground, takkan the thing is silent, right? So it's not like, makes no sense. Okay, you should hear a loud bang. So that loud bang is that 200 calories worth of sound energy. All right, so you get what I'm trying to say here? You are changing chemical energy to gravitational potential energy, GPE. you are converting it to KE, you are converting it to sound. So you see, by this, I can tell you that, okay, I think you can see that energy can only be converted. I'm changing energy from one form to the other, one form to the other. Again, I just keep changing energy. All right. So I hope I make my point here, guys. I hope you can understand this. So this is how energy works. All right. And of course, okay, let's jump to the straight point. Let's jump straight to the point. So GPE, what's the formula? Please highlight this. The formula of GPE is mGh. All right, mGh. Wow, the chat is dead silent. Is it really that boring? Hey, guys, I taught this on Monday, on Tuesday as well. Yesterday, I had one more lesson, okay, Wednesday. And today, just now, previously, I had another Form 3 lesson also. Okay, so this is the 5th time I'm teaching this. And all these 5 times, right, my class is dead silent. Dead silent. You can hear a pin drop. Very, very different from, oh, this is fine. Wow, Rebecca, thank you. So that means, Rebecca, you're okay with physics. So next year, I suggest you take physics. All right, so all the 5 lessons, I have 2 more Form 3 lessons tomorrow. I can foresee the same shit. I can foresee the same shit. Okay, it will be dead silent. Okay, I know this is boring. Okay, I have students telling me, sir, this chapter is very boring. So you choose. You want boring but easy chapter, boring but easy, or do you want interesting but hard? Okay, interesting but hard. Let me tell you next year, when you go science class, right? If you interesting but hard, okay. Yashwini, why are you so why are you so sadistic? Okay, well, Martin, you're similarly sadistic. Okay, anyway, so next year, right, when you go biophysics chemistry, right, do you know which is the most interesting? Biology. Biology is very interesting because you know all the systems you learn. You know all the systems you learn. In Form 1, you learn your what was it called? The homeostasis system. Also slay, okay. Your homeostasis system, you learn your reproductive system, right? And then in Form 2, you learn digestive and your immune system. Form 3, you learn your circulatory and your 5 senses. Okay, and of course, you learn your circulatory system. Sorry, respiratory system. So throughout that 3 years, you have learned like 6 or 7 systems, right? Next year in biology, Form 4, in 1 year, you learn 10. Okay? In 1 year, you learn 10 freaking systems. Okay? Not only in humans, you learn animals as well. Very interesting. I swear, next year when you go digestion, right? You know the Form 2 stuff you learn digestion, it will be even more detailed, more interesting. But that also means more things to memorize. Okay, you thought only like Form 2, oh, vitamin B is for nervous system. If you don't get enough, you get beriberi. Oh, you thought so simple, You have vitamin B1, B2, B6, B12, B5. What's their each function? Oh, very interesting. You memorize and see? So, and you go physics, you're like, what the hell is this? Why is this so dry? But it's the easiest to score. So, be careful what you wish for. You want interesting but hard, right? You be careful what you wish for. Okay, you say yes. Okay. Got the technique to memorize the reactivity. I do. But next year I won't be teaching you already lah. So you can come to me for some memorizing tips. Maybe I can guide you. But next year I don't teach biophysics chemistry already. I'll be in science. Okay, I'll be in science. So anyway, so I used to teach biology lah. 2 years back, 2 years back in DDC, I used to handle biology and science. Okay, now I passed biology to another tutor already. So not my matter. Okay. Anyway, so for our GPE, right, the formula is mGh, m being the mass, G being the gravitational acceleration. Okay, so what the hell is this? All right, for our Earth, right? If you have, it will be fun, okay? You're not trying to suck up to me, right? Okay lah, it will be lah, but I'm not teaching that really lah, okay? Because each tutor is supposed to handle one subject. Okay, anyway, so what is G though? G is 10. Okay, G is 10. Why is it 10? Because Earth's gravity is 10. Unless you go to Mars lah. Mars gravity, if I'm not mistaken, is 8 point something. 8.5, I'm not mistaken. Go and Google search and see. Okay, that means Earth's gravity is slightly stronger. So do you know why we pick Mars? Why does Elon Musk pick Mars? Why is he so obsessed with Mars? Because Mars is the planet that has the closest gravity to us. Right? We can't go to the moon because the moon is 1.6. Right? You jump, you'll be flying. Okay, so technically speaking, if you were to go Mars and do high jump, you can jump slightly higher. Maybe around 10% higher ish. So you can jump higher. That's cool though, right? So for Earth is definitely 10. Okay, Earth is definitely 10. So H is the height. All right, so H is the height. So there you go. That's the formula, mgh. So the question, it is as easy as it seems. All right, so the formula is just mgh lah. So mass is 3 kg. G is 10. Usually they will give this in the question. And then H is 2, because 2 meter ma. So you get 60 J. All right. This is as easy as what we did last week. Just simple multiplication. You don't tell me you know how to do this. Okay, for God's sake, man. Anyway, so 60. 60. That means to lose weight by doing this exercise, for each box you lift, you are going to lose 60 joule. Okay, 60 joule. Is it a lot? Like I said last week, 2 pieces of bread, 2 pieces of empty bread gives you 756,000 joule. Okay, so how many times do you need to squat down to burn this much? You do the math lah. Okay, you do the math lah. So this is a shitty exercise. Okay, so for curiosity's sake 756,000 divided by 60, you will need to squat 12,600 times. Okay, so if you do this for 12,600 times, you will burn that 2 pieces of bread away. Weight loss. Okay, weight loss is achieved. Okay, can you calculate how much is deadlift a certain way? Yeah, it does. Right. Well, since Martin, you mentioned this, right? Okay, I have people who tell me, oh, deadlift burns a lot of calories. Does it though? All right. Let's say your deadlift. Okay, when you lift the bar from the ground, it's 1 meter. I mean, you are lifting halfway, right? Because the bar doesn't go to your head. So even if you are strong as fuck, okay, you can deadlift 200 kg. Goodness me, that's a lot of weight. So you times 10, right? Because mgh ma. So you pull the bar for 1 meter. So how much calories do you burn? You burn 2,000 joule. Okay, 2,000 joule is 2 kilojoule. 2 kilojoule, okay, 2 kilojoule is 0.47 calories. So is it a lot of energy? Freak no. So you don't burn calories or lose weight by deadlifting. You burn it by doing cardio. Okay, so lifting weight doesn't burn energy. Lifting weight doesn't burn calories. Okay, lifting weight builds muscle. Doing cardio burns fat. So which is better? You do both. Okay, because I do both. So no excuse. Anyway, so B, calculate the potential energy of the athlete. Right, so mgh, same thing. So 50 kg times 10 times 5. So this is 2005. So to be fair, doing this exercise is better than doing this. You see, You are burning 2,500 joule by jumping over, by doing a high jump. Okay, so this will be a better exercise. Right, I mean, of course lah, this is a very light box lah. 3 kg is a very light box. So next, see, Ifat and Sam each have mass of 50 and 40 and 55. So let's separate this. Ifat and Sam, they climb stairs with 2 meters. So MGH is 40 times 10 times 2. Whereas Sam is 55 times 10 times 2. So we get 800 joule here. We get 1001 joule here. So what does it mean? Guys, this question shows you that the bigger body you have, the more calories you burn. You learn this in Form 2, right? You know the 6 factors that affect what you eat every day? Your gender, your occupation, your climate, your health condition, your what else? What else? There one of it is your body size lah. So a bigger body, if you have a bigger body, you will eat more. All right. If you compare a 180 cm tall guy who plays basketball, and you compare to another person who is 160, well, of course, the taller guy is going to eat more because he has more mass to carry. Right? Okay, makes sense, Anyway, so D, an object placed at the height of 8 meters from the surface of Earth has GPE of 2000. Okay, so this is a bit different. They give you height, they give you GPE. So what is the mass? Right? So in this case, GPE equals to MGH. They did not give the mass, so GPE is 2000. Now you do it in reverse. G is 10, H is 8. So 80 M. So M is 2000 divided by 80, guys. This is basic maths, so you get 25 kg. Basic maths, You don't tell me you don't know how to do this, Okay, you don't tell me you don't know how to move this thing here, Anyway, I hope I can skip this. I hope I can move along because it's really simple stuff here. So next E, a lift can carry a load of 1005 to a height of 30. So pay attention here, guys. Pay attention here. Number 1, they ask you how much work is done. Number 2, what is the GPE? So work done is energy, right? Like I said last week, work done is energy, right? So work done and this gravitational potential energy, is it the same thing? Is it the same thing? Yes, it is. All right. So work done or GPE, when it comes to height lah, it's the same thing. Right. So same thing. MGH, you have 1005 times 10 times 30. So you will get 450,000 joule. So number 3, what is the relationship between work done and GPE? They are the same. Right? Work done and GPE is the same. Okay, so number 4, what is the power of the lift in kW if the time taken to lift this is 0.5 minutes? So what is energy? What is power? Power is your energy or work done divided by time. So 450,000 divided by 0.5 minute is 30 seconds. Guys, second is the SI unit. You'll be seeing this a lot in physics next year. They will give you different kinds of unit. You can only use SI unit. This is why we standardize everything. You have to go everything back to SI, which makes everything standardized. So in this case, you'll get 15,000 watt. But since they want it in kilowatt, kW, you change it to 15 kW. Please don't tell me you don't know how to convert this. It's like 15,000 gram is equal to 15 kg. Right? You just add another prefix here, which is the K. Okay, so moving on. You guys are fine with it, I hope you are fine with it, If you don't understand anything, please let me know in the chat, So next, elastic potential energy. What is our EPE? This is the formula. 1 over 2 Fx. This is the formula that you should know. So what is 1 over 2 Fx? What is F? F is the force. Right? F is the force. And X is the, I'll just write it here, change in length. All right, change in length. Change in length of what? Of your spring or your rubber band. Okay. This goes for shortening or lengthening. Okay, again, this goes for shortening and lengthening. What does it mean? If I press my spring from 30 cm to 15 cm, my X is 15. Okay, my change in length is 15 cm. Same thing, if I use my rubber band 30 cm, I pull it to 45. I pull it to 45. My X is also 15 cm. Sorry, 15. Yeah, 15 cm. Okay, so X is the change in length. I don't care whether I press it shorter or I pull it longer. Same thing, the change in length is X. Right, so let's jump straight into this. 1 over 2 Fx. So F is 5. X is 25 cm, right? Remember, you cannot use cm. You have to change this to SI unit, which makes this 0.25 meter. So this answer, you will get 0.625 J. Okay, so is this spring going to hurt you if I bounce it on your face? No, because it's very little energy. Right, very little energy. Guys, too much of an energy can kill you. Right, too much of energy can kill you. This is why, if you are in a car and you crash it into a wall, you die because all the energy is transferred to you. This is why bullet can kill you, because a bullet has high enough energy to puncture your organ, okay, to go into your body. So high enough of an energy can kill someone. So this is why your car safety features, right, like those airbags lah, the front crumple zone lah, the bumper lah, the seat belt lah, everything is to absorb the energy away so that the energy doesn't transfer to the passenger. Make sense, right? So next B, same thing. So 1 over 2 Fx. So F is 60, X is 0.2. Okay, because 20 to 40 is 20 cm, so 0.2 cm, 0.2 meter. So in this case, you will get 6 joule. All right, next C. A spring with a length of 20 cm compressed to 2 kg, until it decreased to 12 cm, so 1 over 2 Fx. F is 20, X is 0.08. Why is it 0.08? Because 8 cm. 20 to 12 is 8 cm. So 8 cm is... Oh, I'm going quite fast. Do I need to slow down? Do I need to slow down? Okay, do I need to slow down? Oh, later. Okay, sure. Because I just want you guys to understand, you just sub your value in. The rest of it is just maths. The rest of it is just maths. So I don't think I need to do maths for you, right? Okay, anyway, so next D. So same thing, arrow pulling an elastic bowstring. So F is 25 because it's here, and then the X is 0.5 because they just say it's pulled from original position for 0.5. So we just sub everything in. So the answer is 6.25 joule. Okay, I will let you digest this. Okay, anyone has any question? You just need the formula, sub everything in, and that's your answer. As easy as it gets. Right? Because the hard part is not here. The hard part is next week, where we are going to learn about the conversion of energy. Maybe we'll go into that later if we have the time. Okay, so I move on. I'll move on. Okay, let's go to KE. This is the last part, kinetic energy, tenaga kinetic. So as I said, anything by a moving object, you have kinetic energy. So this is the formula. Half mv squared. Okay, half mv squared. So what is m? Same thing. M is our mass. What is v? V is velocity. Okay, velocity. Do you know what is velocity, guys? Any one of you know what is velocity? Not the more. Okay, what is velocity? Anyone? Have I mentioned this before? Have I mentioned this before? Anyone here knows what is velocity, guys? Anyone? You'll be learning this in physics next year. Right? You'll be learning this in physics. So, what is velocity? Okay, what is velocity? Velocity, yes, it's the same as speed. Okay. Wow, Rebecca, how do you know? How do you know? Have I mentioned this before? Have you all learned this before? This word might seem a bit new to you, huh? Velocity is the same as speed. Alright, in BM, this is called hal laju, and speed is kelajuan. Alright, so I'm sure you have a question here. Sir, why do they need to split leh? Since they're the same thing, why don't you just stick to one word? Because they are a little bit different. Alright, velocity comes from displacement, and speed comes from distance. Okay, so what's the difference? It's the same thing too. It's just that, okay, this might sound very bullshitty to you lah. Alright, if you have point A and point B, if you have point A and point B, if I go from A to B in a curvy line, this is the distance. The total thing you travel is the distance. But displacement doesn't care about how much you travel. Displacement only cares about the straight line. If you go straight line from A to B, that's the displacement. But essentially, they are the same thing. It's also distance lah. It's just that displacement is straight line distance, connecting the starting point to the end point. You might say, okay, sir, why so lebe leh? Why need to split into two leh? Beats me. Okay, even I don't know. So in this case, when you are measuring the speed of straight line distance, we call it velocity. When we measure the speed of the total distance, we just call it speed. Okay, so whenever you see velocity, you just treat it as speed lah. It's the same thing. Alright, because in your levels, you don't need to separate what's the difference between velocity and speed. They are the same. Okay, same. Right, anyway, so A, when a train of mass 500,000 kilograms, moves with a velocity of 360 kilometers per hour, how much kinetic energy is possessed by the train? Guys, do you know how to convert this? Do you know how to convert this? Anyone? Do you know how to convert this? Why do I need... Okay, first of all, why do we need to convert? Because kmh is not the SI unit. The SI unit is meter per second. Alright, because meter is second, so meter per second. So, how do you convert this? If you still remember, you learn conversion in maths, right? You'll be doing this a lot in physics next year. So, kmh is 360. You change it to meter per second. So 360 km is 360,000 meter. 1 hour is 3,600 seconds. So in this case, you will get 100 meter per second. Okay, 100 meter per second. So change it to meter per second first. You cannot just put kilometer per hour into the question. So 1/2 mv square. So m is 500,000. V is 100 and then square. Alright, so since this is a really big number, you should express this in standard form. Alright guys, express it in standard form. So what's the answer here? I don't know. Okay, you calculate this yourself. Just press the calculator and count the zeros yourself. Right? Because the answer is not the point. The answer is whether you understand the formula. So 1/2 mv squared. All right, are you guys following? I hope you're following. I hope you're following. So, okay, one more thing. One more thing. Do you see this speed? Do you see this speed? 360 km per hour. That's a very, very fast speed. All right, so what is kilometer per hour, by the way? This is the unit used in our car, right? This is the unit used in our car. I'm sure you know this, when your dad or your mom drives on the highway, when your dad or your mom drives on the highway, what's his or her speed? How fast does your dad or your mom drive? Our Malaysia National Highway limit is 90 or 110. Plus highway is 110 lah. Let's say you drive from KL to Penang, right? The speed should be 110 unless they state there 90, so you have to follow lah. But usually, do we follow? Do we follow the speed limit? No. Okay, I don't know about you, but at least I don't. Okay, if you want me to drive 110 all the way to Penang, I'm gonna sleep. Right, so I'm sure your dad drives like what, 140, 150, you know, around there lah. Okay, if he's a faster person, maybe he drives 180 or 200. Okay, 200 is a bit scary already lah. Anyway, so about this thing, right? You see here 360, right? All right, so let me talk about, you know, let me go off track, go sidetrack a bit and talk about this. Guys, do you know what kind of train goes 360? You know what kind of train goes 360? You know how fast is 360? Okay, 360 is from here to Penang in 1 hour. Okay, yes, that's the bullet train. Right, that's the bullet train. So bullet train goes, they can even go faster. In Japan, right? In Japan, okay, Japan is very famous for their bullet train. So Japan's bullet train can go up to 600. Okay, can go up to 600. 600, to put it in perspective, 600, that means from Penang to Johor in 1 hour. Okay, Penang to Johor in 1 hour. Okay, you drive, you need 8 hours, without jam, you need 8 hours. So with the bullet train, you need 1 hour. Wonder how does it feel like? Okay, I'm glad you asked, Yafini. I'm glad you asked. So guys, let me explain about bullet train. We call it a maglev train, by the way. Maglev stands for magnetic levitation. Okay, magnetic levitation. Yes, you heard it right, levitation. That means the train, it levitates above the track. This is why it can go so fast, right? Because you see, normal train cannot go that fast because of the friction. If you go that fast, your train is gonna derail. Okay, but since this doesn't happen because it has no friction, this train has zero friction, so it can go really fast. As you can see, they use super magnet, okay, which is called a superconductor. They use it to make super magnet, and the train just floats on the track. Crazy, right? Okay, so this is how fast it goes. You see, even the shape looks like a freaking bullet. Start a fire. Yes, it will start a fire. So about this maglev train, right? You know what's the best thing about it? It is really stable. Okay, really stable. You look at this video, you understand. Okay, even coins and pen, they do not drop. Okay, because this is levitating. Yeah, so aerodynamic, yeah. So because this is floating. This thing is floating. So since there's no friction, there's no vibration. No friction, no vibration. So this thing can go however fast you want. All right. Talking about this, do you know Malaysia planned to build one? Last time, during Najib's time. Okay, during Najib's time, he planned to build one. What if it loses control? Okay, I'll talk about the losing control later. All right, so Najib's time, right? He proposed a high-speed rail project. from KL all the way to Singapore city center. Okay, that was the plan. That was the plan. That means you can reach Singapore from KL. Okay, you want to go Singapore, you can reach there in 1 hour. You can reach there in 1 hour. So let's say it's a Sunday morning. You say you want to go Singapore to shop. You want to go there shopping. If you have the money, okay, so you will jump on this high-speed rail. You will go all the way there in 1 hour, and then you shop all you want, and then you come back. Okay, and on the way they will stop. Any southern states lah. They will stop in Malacca. They will stop in Seremban. They will stop in Johor, and then to Singapore. That means from KL, that was the plan anyway. That means from KL to Malacca takes 20 minutes. KL to Malacca, 20 minutes. If you drive, it's like what? 1.5 hours or 2 hours. 20 minutes you can reach. It's like if you're in Puchong, it's like jumping on an LRT and then you go Bukit Jalil. From Puchong to Bukit Jalil, that's around 20 minutes. It's like that. All right. So imagine how crazy this is. And turns out what? When after the general election, the previous general election, so Najib lost, right? And then only they found out this high-speed rail, it uses too much money. Okay, too much money. Well, what's the surprise? Najib took much of it. So because of using so much money, right? So they say Malaysia cannot afford this thing. Okay, well, shamefully we can't afford it. So they scrape the plan. Okay, bummer, right? Okay, I was not gonna lie, I was a little bit bummed out. Okay, I was like, wow, Malaysia has its first bullet train because Taiwan has this thing. So in Taiwan, if you want to travel from Taipei to Kaohsiung, okay, Taipei to Kaohsiung is like Johor to KL, 300 something kilometers. So from Taipei to Kaohsiung, right, they will just jump on the high-speed rail. 1 hour you will reach there. So you can have this in your dream because it's not gonna happen now. Malaysia is too poor for it, guys. $1 to 450 ringgit. For shame, for freaking shame. Okay, you think you can afford that? You can afford that iPhone now? No, even sell kidney you also cannot afford because Malaysian ringgit sucks. Okay, you might not have to use everything. Yeah, I agree. So this is why China they built a lot of high-speed rail. Okay, because they rather you not take the plane because plane is very fussy, very troublesome. You have to build airports and that. Okay, so talking about this maglev train, right? Okay, it brings my attention to this thing called Shinkansen. Okay, you know what guys? Do you know what is Shinkansen? This is the bullet train system in Japan. All right. So Yashwini, just now you said, right? Wouldn't this thing be dangerous? Japanese Shinkansen is built to withstand earthquake. All right. So in case you didn't realize, Japan is a very earthquake prone and tsunami prone country. So their train has the sensor of earthquake. So when there's earthquake, they will slow down. Okay. Yeah. So I think they did. So about this Shinkansen, right? First of all, it's really expensive. It costs more than airplane tickets. Okay, because my friend went there. She traveled from Osaka to Tokyo. She traveled using plane. So I was like, why didn't you take the Shinkansen? Because she said it's really pricey. It's like twice the price of a plane. Okay, well, because it's faster and this thing is quite hard to operate. Right? So, but that's not the point, okay? That's not the point. The point of this thing, right? What my friend told me, the Japanese trains okay, I'm sure some of you already know this. The Japanese public transport, the Japanese trains they are so freaking efficient. 30 seconds is considered late. Do you know that? That means if your app there's an app that for you to track the train. If the app says 4 p.m. 4:12, that means 4 o'clock 12 minutes and 0 seconds, the train will reach the station. That means that time exact second they will reach in front of you. If it is 4 o'clock, 12 minutes and 30 seconds, the train is considered late. 30 seconds is considered late in Japan. All right. So that means trains in Japan, it's plus minus 5 seconds. All right. For the whole year, they will the time of them reaching each station, the difference is 5 seconds. It is never late. All right. So in Japan, saying that your train is late is not a valid excuse at all. At all. All right. Telling your teacher or your boss the train is late is like saying your dog ate your homework. Okay, it's ridiculous. Okay, so in fact, I think I told this before, right? Okay, if you are late, right? If the train is late, touch wood lah. Yeah, exactly. So if it's late, right? They will issue you a late certificate. All right, there's a certificate of being late to show it to your boss, like you see, legit, the train is late today. So no, it's not gonna happen. All right. And if it really happens, which is very rare, the train conductor will bow to you one by one. Okay, the train conductor will go around the train and they will bow to everyone. Sorry for being late. Okay, because it's not possible. Okay, Japan train is never late. No such thing. So Malaysia, within 5 minutes, you should go alhamdulillah already lah. Right. I mean, I'm not trying to shit on Malaysia system, but that's the reality. LRT is okay. Okay, LRT is okay. Have any one of you tried taking the KTM? Has anyone of you tried taking the KTM? That is the absolute dog shit system. Have you tried? You try once, you will know. Okay? First of all, every train is 30 minutes. 30 freaking minutes. Okay? 30 freaking minutes. It's never on time. It's crowded as shit, smelly as shit. Okay? And it's always delayed. And you know what's the best part? If there's a flood, if it's raining heavily and if there's a flood, the train will cease to function. Okay? Just like your Astro lah. Raining cannot watch one. Okay? So raining, if there's a flood, the train will not work. You know why? Because the engineers, they are so smart. They design the track, some of it, when it rains, it will be submerged underwater. Big brain. Okay? You would think that we spend so much freaking money, they at least have this kind of, there's no such oversight like this. Well, guess what? It does. All right? Because it happened to me. Last time my wife stays in Seremban. Okay, my wife stays in Seremban. So every time she wants to come KL, she will take the KTM. And then there was once she said, can you come fetch me at Nilai? Okay, Nilai is halfway. So I was like, why fetch you at Nilai? Oh, because according to her, the train will stop at Nilai because after Nilai, right, the train tracks are underwater. Awesome. So at Nilai, right, the train conductor has to chase every one of you down the train. And then what happens now? You go fuck yourself lah. Okay, you go fuck yourself. Okay, so I have to go all the way to Nilai to fetch her. You see how stupid this is? Hey, the train is not cheap, Our taxpayer money, you design it in such a way that the tracks will be underwater. Do you get a refund? Do you even care about refund at this point? So bad, right? So bad. So guys, if you have the money, please don't take the KTM. Okay, you would rather drive instead because that's the absolute dog shit of public transport system. Okay, and those ministers, they say, oh, Malaysians don't take the trains. Malaysians are so pampered. You know what is this? You know the Dato said that. They say, oh, KL is full of jam, full of cars because you Malaysians are so pampered. Cakap je pandai. Korang cuba lah. Korang cuba ambil train. This is called sembang kari. Okay. So Malaysian for you. Okay. Okay. Talking about this makes me want to cry. Okay, so shameful. Okay, anyway, so next B. You know what? Just sub everything in lah. Okay, so many grandfather stories to tell today. Okay, yeah. If not, later you'll say very boring. Okay, so 3.6 square. All right. Wait. Oh, it's 3.6 joule. That's the KE. So they want you to calculate the velocity. Okay, to calculate the velocity. So cut 0.1. So V square equals to 36 because 0.1, 3.6 divided by 0.1, it's 36. So when you throw this there, it becomes V square root. Guys, for the love of God, this is maths. You don't tell me, you don't ask me, oh sir, why is square coming here become square root? Okay, I will choke slam you. All right, so C. 9 times 10 power negative 31, and then this is V. Oh my God, why is this number so big? Okay, solve this yourself lah. I'm just gonna sub everything here, and you can do the calculation yourself. All right, press the calculator yourself, please. Thank you. Next, a superhero with a mass of 50 kg, constant speed of 800. Wow, what superhero can fly that fast? Hey guys, you know how much is 800 meter per second? For comparison, the speed of sound is 330 meter per second. This is the speed of sound. That means this superhero is supersonic. Okay, supersonic, almost like what? 2 times plus the speed of sound. Okay, supersonic. Well, this superhero makes no sense lah. Why is he 50 kg? He's a skinny little ass bitch. I'm sorry to say that, okay? What kind of superhero is 50? Goodness me, so skinny, eat lah. Okay, so D. A flea weighs... Yeah, exactly, man, yeah. Maybe it's the Flash, who knows? Oh, wait, no. Flash is quite muscular too. Anyhow, so a flea weighs 0.5 mg. Okay, so what is mg? Mg is milligram. So 0.5 times 10. Guys, milli is 10 power of negative 3. You learn this in Form 1. Tera, giga, mega, kilo, deci, centi, and so on. Okay, so milli is power of 3. Right, so 1/2 times 0.5 times 10 power of 3 and 1 squared. Okay, so do this calculation yourself, please. I'm not gonna, bother with this. All right, if you can write this correctly, but somehow along the way, you press the calculator wrongly, and you got the answer wrong, I really have no words for that. Okay, I feel sad for you, okay? I feel sad for you. For real though. Okay, make sure next time your job doesn't involve pressing any buttons. That's all I'm gonna say. Okay, because you're not the sharpest tool in the shed. Well, okay. If your job is to launch the nuclear weapons, I might afraid that you will press the wrong button. Big oof. Alright. Anyway, wow, shit, I have no chill today, right? I have no chill. Anyway, so you know what? The rest of it, okay, let's talk a little bit about this conservation of energy. We are supposed to go into this next week, but you know what? Let me talk a little bit about this thing. This is where things starts to get a little bit complicated. Okay, let's look at what is conservation of energy. All right, this in BM is called keabadian tenaga. Okay, keabadian tenaga. So what does it mean? That means, like I said just now, conservation of energy states that energy cannot be created or destroyed, but can only be converted from one form to the other. That's what I say, right? You have 200, like just now, 200 joule of chemical energy. You climb the stairs. You have 200 joule of GPE. And then when you jump down, you have 200 joule of KE. And then when you reach the ground, you have 200 joule of sound. You see? You don't just lose energy for no reason. It is still within that system. Okay, you cannot create or destroy energy. So that's the meaning of conservation of energy. All right, so we have two things here. We have the simple pendulum here, and we have a loaded spring here. So guys, we can just ignore one part. We can just understand this because it's the same for both. All right, so what happens here? What happens here? So we see this pendulum. You know what's a pendulum, right? Okay, so you pull this thing up, and then this thing will start swinging. Yay. This is called oscillation. Right? It's an oscillation. So what happens here? When you pull this thing all the way up, right? When you pull this thing all the way up, right? So can you see at position X here? At position X here, you have maximum GPE because it is at the highest. If you still remember, GPE is about height, right? GPE is about height. So when you have the highest height, you have the highest GPE, right? Common sense, right? And then at the beginning here, since you're not moving, you have 0 KE. Like I said, kinetic energy is about movement. So do you have any movement here? No. So you have 0 KE here. And then as you start to swing down, you slowly convert this GPE into KE, as mentioned here. You see? GPE decreasing, KE increasing. Because you are slowly losing height, you are slowly gaining speed. Losing height, gaining speed. Losing GPE, gaining KE. Right? Because GPE is about height, KE is about speed. So when you lose height, you lose GPE. You gain speed, you gain KE. So when you reach here, when you reach Y here, you will have 0 GPE or minimum GPE, but your KE is now max. Because all GPE is converted to KE, right? Okay, let me put this in number, then you will understand. Let's say at the beginning you have 400 GPE, but you have 0 KE. Halfway through here, you will have 200 GPE, you have 200 KE. And then when you reach point Y here, you will have 0 GPE and you have 400 KE. So can you see what I'm trying to say here? You are slowly converting your GPE into KE. And then when you swing back up, okay, you will change it back lah. Yeah, you know what? I'm getting ahead of myself. Okay, I'm gonna talk about this next week. All right, so guys, I know it's a very boring lesson. Bear with me for one more week, which is next week. And when you go to chapter 8, things will get so much more interesting again. All right, so thank you for coming. Okay, I will see you again the same time next week. Hope you have a happy Thursday. Okay, I will see you again. All right, so take care. See you. Good night and